Hi, welcome to AB Video 7.2D Part 2, more on volumes by cross sections, and this is the end of volumes. That one's very similar. Okay, now we're going to take equilateral triangles. Same base, still perpendicular to the x-axis, but the cross sections are now equilateral triangles, okay? So now it looks like this, where you have an equilateral triangle, and this is 2y. So I'm going to go over on the side here. If this is 2s, then if I drop the perpendicular, this is s. This is a 30, 60, 90 triangle. That's s, 2s, and s root 3. The area of the equilateral triangle is 1/2 base times height, which is 1/2 2s times s root 3, which ends up being s squared root 3. Okay? So ours is 2y instead of being 2s. So it's s squared root 3, which in our case is y squared root 3 or root 3y squared. Then all you do for the volume of the slice is stick a dx on that because it's perpendicular to the x-axis. And for the volume of the solid, you take that expression, stick an integral. That's x, so it has to go from left border to right border. And again, you can't leave the y there, but y squared is equal to 4 minus x squared. And again, they could do 2 times 0 to 2. Okay, same thing here. Let me show you actually one with a circle base, but now the cross sections are going to be semicircles. So let me show you that. Here we go. Oh, no, that's not what I want. That is, oh, are there more? Oh, I didn't know you could do that. This is a right triangle with semicircles. You know, I don't think she has a circle base with semicircles, so never mind. Okay, so there's our circle base. There it is at an angle. Perpendicular to the x-axis means parallel to the y-axis, but this time we're putting semicircles onto that, okay? So the cross section is a semicircle. Its radius is y. Therefore, I mean, this is 2y, but we use the formula with radius, so which is y. So it's 1/2 because it's a semicircle pi r squared, so it's 1/2 pi y squared. Perpendicular to the x-axis, so for the volume of the slice, I'll just stick a dx on that. For the volume of the solid, I'll take that whole expression right there and integrate it. That's x, so it goes from left border to right border. And again, I can't leave the y squared, which is 4 minus x squared. Or again, they could do 2 times 0 to 2 or 2 times negative 2 to 0. Okay, again, circular base. The book is very unimaginative. It's the circle base, circle base, circle base. Now the cross sections are isosceles right triangles with a leg on the base. So here's what we have now. This segment right here, perpendicular to the x-axis, is now one of the legs of an isosceles right triangle. So here's the other leg, here's the hypotenuse, okay? So now we need to find the area of that triangle. Sorry, that doesn't look like a right angle, but it truly is. So we have, this is 2y. Well, if it's isosceles, that's also 2y. So 1/2 leg times leg becomes 2y squared. It's perpendicular to the x-axis, so I stick a dx on there. And then I add it all up. It's x, so it's left border to right border. The y squared I can't leave, and again, y squared is 4 minus x squared. So you're starting to get the drift. This is not all that bad. Okay, now a little bit more difficult. The base is the region between the parabola y equals 4 minus x squared and the x-axis. The cross sections perpendicular to the y-axis are semicircles. Okay, so first of all, here's our base. I'm looking at it aerial view. I have the parabola y equals 4 minus x squared, which has x-intercepts at 2 and negative 2. And the other border of my region is the x-axis. So this now becomes the base of our very bizarre house. That's our foundation right there. So I drop it down, but now I'm going perpendicular to the y-axis, which means I'll pick a point on the y-axis and draw parallel to the x-axis until I get to the edges of my base. All right, now I draw a semicircle. This, of course, is x. This is also x. Now, that happens to be a property you might not be aware of, but when you draw a chord perpendicular to the axis of symmetry in a parabola, that chord is bisected, just like it is when it's a chord perpendicular to the diameter of a circle. So if this length is x, that length is x, which means we have a 2x diameter or an x radius. There's your area of your semicircle. Then you take that expression, stick a dy on it because it's perpendicular to the y-axis. And then that's y, so now it's going to be from the bottom border of y equals 0 to the top border of y equals 4. And of course, I cannot leave the x squared there because it has to be in terms of y. But if you come back up here, x squared is 4 minus y. So you just isolate x squared and you get 4 minus y. Here's another one. The base is the triangle enclosed by x plus y equals 1, the x-axis and the y-axis. Cross sections again perpendicular to the y-axis. Pay attention to that. Again, semicircles. So here's the x-axis, the y-axis, and this is actually the line y equals negative x plus 1, which has a slope of negative 1, y-intercept of 1. So now this is our foundation of our house. And perpendicular to the y-axis, so pick a spot on the y-axis and draw perpendicular to the y-axis, which means parallel to the x-axis, to go from one end of the shaded base to the other end. And now we have semicircles. So this length here, the diameter this time is actually just 1x, which means the radius is x over 2. There's your area of your cross section. Stick a dy on that because we're perpendicular to the y-axis, and then set up your integral. It'll be from the bottom border, which is y equals 0, to the top border of y equals 1. And then we got to get rid of the x squared. You go back up here. X is therefore 1 minus y, and therefore x squared is 1 minus y squared. Okay, and I don't have to, I want x squared, so x squared is 1 minus y squared. Oh, look, there's another one. The base is the region enclosed by y equals x squared and y equals 3. Cross sections perpendicular to the y-axis. Again, this time are squares. So here's y equals x squared. Here's y equals 3. Here's our region. So I drop that down perpendicular to the y-axis. Again, this is going to get bisected. So if this length is x, this length is also x. So the whole thing is 2x. And therefore, the area of the square is 4x squared. Stick a dy on that and integrate from the bottom to the top, which is y equals 0 to y equals 3. And again, replace x squared in terms of y. Well, x squared is equal to y. And there's the integral that you would actually integrate. By the way, most of these integrals are not very difficult.